Hello and welcome. Today we are going to talk about creating cleaner and more organized blueprints. We will start with the definition of clean coding. What is clean coding? And we will continue with the naming conventions that will help you create meaningful variables and components. Our third topic will be about variables in general, variable descriptions, variable categories, and variable ranges with variable sliders. Then we will learn about exposing variable and making variable instance editable. We will conclude our chapter about variable with the private variables and their intended usage. Then we will continue with the functions and started with the function definitions and keywords. We will continue with the private keyword for the functions. Then we will encapsulate our nodes with the comments. Then learning the technique of collapsing your nodes and collapsing them to a function. Then we will learn what sequence and flip-flop nodes are and how they can help to improve our overall algorithm's readability. Then we will conclude our tutorial by aligning blueprints. With this being said, let's start with the definition of what clean code is. Well, what does clean code mean? What is clean and what is dirty in terms of coding? Clean is an umbrella term for the overall quality, extendability, and maintainability of your code. If your code is clean, that means someone else is able to read and understand your algorithm easily. Then she or he is able to extend your algorithm and codes based on its purpose. Let's look at two different examples of blueprints to decide which one is a good example of clean coding. On the left side, we have some wires and nodes tangling around and trying to survive in this mess. There is no possibility that we can understand and tell its purpose at the first glance. On the other hand, here is the good example of clean coding principles used with blueprints. They are organized with good naming conventions and well covered with a thoughtful commands. That is what you will be to do at the end of this tutorial by understanding the rationale and the reason behind of these principles. By keeping them in mind, we will start our first topic, naming conventions. Naming convention is a standard for naming your assets, variables, or even comments. If you have standard in naming throughout your whole project, that means your fellow developers and even you will be easily to understand your project when it is getting bigger and bigger. Here is one illogical naming for function. It's only a name. It is not a verb. We have no idea what to do with this noun. Does it get name? Does it set name? Or even does it check name? We don't know anything about it. On the other hand, here is a meaningful naming for a function. It starts with a verb, continues with a noun, which gives you clear understanding of the purpose of this function particularly. The function name getName shows clearly that it only gets name. If you follow this principle while naming your functions, they will be always goal-oriented and nothing unnecessary will get into them. Next, we have variables. Like functions, variables should also have a standard in terms of naming variables will be mainly depending on the content we are working on. On the left side, we have two different Boolean variables naming isPlayer walking and equipped. At first view, both variables will seem okay, but we have two main problems here. If we use is as an indicator here, we should continue with this name, which means both variables should start with is. If we don't, both variables should omit this verb. The second problem is we have an unnecessary noun in the first Boolean variable. We are already in the player blueprint, so player noun is unnecessary here. Despite of being unnecessary, it also causes a confusion, which means that it looks like we are trying to access different blueprint, like player, outside of this blueprint. So as said, since we are in the player blueprint, we already know that we are holding the information related to this player. When we look at the second variable, its naming is so vague. I mean, we don't know what is equipped. Is armor equipped? Is weapon equipped? They are totally different. So for example, if we are using this boolean for weapons, then it should be is weapon equipped. Therefore, we are sure that this boolean is primarily used to check if some kind of weapon is equipped or not. The last topic that we will cover in naming conventions is actor components. While naming different Unreal Engine assets like skeletal mesh, static mesh, or even animation sequence, we have different online resources to take a look at and create our very own naming convention setting. I want to mention my two online resources for naming conventions. First one is Epic Games' original website, and second one is unrealdirective.com. You can find these links in the description below. However, you don't have one single way to name your assets or variables. Don't forget that important point here is to have a standard throughout your whole project in terms of naming. With that being said, let's look at the example of these actor components. By looking at the icon of it, we can easily tell that it's a skeletal mesh, but the naming doesn't help at all. What is mesh? Is it player mesh or is it some kind of weapon mesh that player can equip? We don't know that. More meaningful usage will be skm_player. With this name, we clarified it. We are using skeletal mesh and it is for player. With this naming convention, we clarified it. We are using skeletal mesh and we don't have to remember all of the symbols used throughout the engine. The next noun, which is player, indicates that we are using this skeletal mesh to animate and visualize player, nothing else. So we conclude our first chapter, naming conventions. We have two major takeaways for this chapter. First one is that we should be able to easily understand the purpose of variable, function, or component at the first look, so that other team members will be easily follow along your blueprints, and even you will be able to understand your blueprints after a day or two. Second, there is not a single strict rule that you should follow in terms of naming. There are some online resources to help you understand the philosophy of naming conventions. But the key point is you have a standard in naming throughout your whole project when it is getting bigger and bigger. Now we will continue with the variable categories. All variables will have a default category. And when you continue to create new variables bluntly, and not paying attention to their category as well, you are simply exploiting this category. On the other hand, category is the meaningful way to separate your variables according to their use cases. On the left side, we are not using a custom category for a variable, which means that when number of variables grows, there will be a pain to search for a specific variable in the category. On the right side, you will see that all variables are categorized according to their use cases, and it is much more easier to find what we are looking for. While setting a category for the variable, we have clear goal in our mind to use this variable for. But this purpose can be vague for other team members or for even you after a day or two by looking at the variable category alone. To keep this purpose written, we have variable descriptions. After giving your variable a category, don't forget to direct your fellow team members about the usage of this variable later on. Now let's see how we can set variable category and variable descriptions in the Unreal Engine. Now we will see how we can organize our variables with variable categories and variable descriptions. On the left side, we can see our variables, but they are not in any order. They are not organized. We should set meaningful categories for them. We can categorize our variables by their purpose. We have ammo count and is a weapon equipped. It is clear that both of these variables will be used for weapon-related events. So we can easily set our variable category as weapon. To set our variables category, we can use the details panel on the right-hand side. As you can see, the category is default. We can change the text here to set our variables category, like weapon. When we set custom category, it is immediately displayed on the left-hand side of the variables. I will do the same thing for the ammo count as well. Once I have set the new category, then I can select this category by clicking the drop-down button. After setting the weapon category, I can now focus on other variables like health and armor. Both of these health and armor variables are related with player attributes, so I can easily set their category to attributes. I will do the same thing for the armor variable. For the last three variables, I have a clear purpose that they will be used for animation purposes. Is on air, is walking, and is armor equipped, so that I can set their category to animation. After setting their category, I can continue with the descriptions. Is weapon equipped, for example. I can tell other developers that this boolean will be used mainly for shooting mechanics. So let's say used to check if player can shoot. So when I hover my mouse on the variable, it will show my description. Used to check if a player can shoot. So I will do the same thing for the ammo count. For example, shows the current ammo of player. I can follow the same principle for remaining variables. Like for example, for the health attribute, I can set the description as. So for example, for is walking variable, I can set the description as use the check for animation transition. So I will also prevent other developers to use this variable for something else. In the previous chapter, we learned how to use variable categories and variable descriptions to give our variables a clear purpose of usage. Now we will learn variable ranges and value sliders to give appropriate variables a limit of range. Variable slider is the slider that we can use to set maximum and minimum values using engine slider. On the other hand, the value range is the maximum and minimum values that a single variable can get, independent of the slider and value we can assign to them. For example, if we set the maximum ammo count to 15 and set its value in the blueprint somewhere else, to 20 maybe, then its value will be clamped to 15, no matter how high the number that we assign to it. The same logic applies to minimum values too. For example, if we set the minimum value of ammo count is 0, then maybe somewhere else we can make its value as minus 50. It will be clamped to 0, no matter how low the value is. These two constraints can help us to determine the value's range while creating the variable. And by setting those limits, we can prevent other developers to misuse these variables. Let's now look at how we can adjust these maximum and minimum values in the Unreal Engine. By clicking the integer, float, vector, or rotator value, we can adjust their value ranges and slider ranges. In the Details panel, when you click on the variable, in the Details panel, you will see slider range and value range right under the category. For example, we can set minimum value and maximum value of ammo count, something like 0 and maximum 20, and so the value range. Therefore, as you can see, we can adjust the slider to a maximum 20 or minimum 0. Therefore, we prevent other developers as well as you to misuse this variable. So in the previous chapter, we learned how we can set limits to value ranges and variable ranges. This option helps us to indicate better the use range of these variables for other developers as well. Now we will talk about exposing variables and how it can improve readability of our codes. Exposing variable on spawn means you expose this variable on its own actor, which gives us the opportunity to tell other developers that you should fill this variable at the beginning of spawning its own actor. Talking about exposing variables on spawn, we need to learn about the connected term, which is instance editable. To expose your variables on spawn, you should also make this variable instance editable. Making your variable instance editable means you let other blueprints to access this variable outside of its owner blueprint. In terms of programming, these type of variables are called as public variables, which means that they are publicly available throughout the project. It is logical that you also have to make your variable instance editable because you are accessing this variable outside its owner actor, in which where you are creating this actor, which means you are accessing this variable outside of its blueprint. With this being said, let's go into the Unreal Engine and see a practical example of exposing variables on spawn. For example, when I spawn this player character, I may want to set health and armor. When I select one of these variables in the Details panel, I can click on the Instance Editable checkbox and Expose on Spawn checkbox. Make this variable publicly available and exposing it on spawn. I will do the same thing for the armor variable, Instance Editable and Expose on Spawn. I will click Compile and Save. In the level blueprint in Begin Play, when I spawn actor from class, in which here is the BP character, we will have both health and armor variable to be set when spawning this blueprint. In the last chapter, we talked about instance editable variables and exposing variables on spawn. We learned that making the variable instance editable means making this variable also publicly available throughout the project. In programming terms, it means making the variable public. On the other hand, we have another option. We can keep this variable secret. It means making the variable private. And private variable means that you inform yourself and other team members as well. The variable's usage and accessing to it is only intended within its blueprint. You remember our animation variables, right? Is walking, is armor equipped, is on air. These are all supposed to be used in the character blueprint only. At this stage, let's try to access, for example, is walking variable outside of this blueprint. In the third-person map level blueprint editor, I have spammed the character actor, and now I will try to access the is walking variable. So, for example, set is C. I can easily set is walking variable outside of its blueprint. This is a good example of misusage, this variable. Then in the character blueprint, I can set the isWalking variable. In the character blueprint, I can click isWalking variable, and then I can make this variable private. Then this variable should be only accessible inside of its blueprint. So I will compile and save. Then in level blueprint, when I try to compile again, I will get error indicating that variable name is private and not accessible in this context. By doing so, I can be sure that the isWalking and other types of variable that should be intended to use inside character blueprint cannot be accidentally accessed from outside its blueprint. We learned that we can give a variable description to clear its purpose of usage. We can also set variable ranges and value ranges for appropriate variables to constrain users to its intended usage range. Lastly, we learned that we can expose variables to show that this variables is intended to be filled when it's created. Now we continue with the functions and how to increase their readability. When creating a function, we should have a clear purpose in our mind to use it. And with that in mind, we should start with a verb, because functions are a group of blueprints that gives us something, that achieves something, and oftentimes returns something. After starting with a verb, we should continue with the noun. For example, what do we want to get? What do we want to set? Or what do we want to find? These three words are a good starting point to find out the purpose of the function. Let's go into the Unreal Engine and see how we can give a definition to a function. Now we have setMo function. In setMo function, we get integer variable and set it to mo count. Our mo count should not be greater than 20, but developers should easily set this value to something like 50 or even 100. By preventing this misusage, let's click on the setMo function, and in the description, we can set something like mo count should not be greater than 20. This way, we can prevent its misusage and direct developers that the maximum mo count should be 20. As we learned, we can use function definitions to give other developers a clear understanding of what this function will do. Once we give this clear objective, the other enhancement that we can do is improve its searchability by giving it a meaningful keywords. By doing so, we can easily find these blueprints with intuitive keywords instead of trying to memorize its name. Let's go into the Unreal Engine and see how we can give function a keyword. To set keywords for a particular function, you can click on the function, and in the details panel, you will see the keywords box. You can enter your keywords with separated by comma. For example, clear mo, POZ, for example. Let's enter something fancy and try to find this function with this keyword. When we enter these function keywords, it will set it. And then when we click on the right mouse button, start typing POZ, we will see setMo function comes up. This way, we can increase the findability of this function. We discussed that how we can improve our function's readability by supplying function definitions. And we saw that we can make our functions easy to be accessible by giving some meaningful keywords. Now we will discuss our final topic in functions, which is private functions. Such as we learned in variables, we can also make our functions private, keeping it accessible only within the blueprint it is created in. Therefore, we can prevent unintended access to this function outside of its blueprint. Now let's go into the Unreal Engine and see how it's done. For example, while defining setMo function, our intended usage could be accessing it from within the character blueprint. By clicking the function name in the details panel, we can change the access specifier from public to private. By doing so, this function will be only accessible from within the blueprint. Any unintended access to this function outside of its blueprint will be prevented. In last chapter, we can modify our function description to improve its readability, add keywords to improve its searchability, and make it private to prevent unintended access outside of its blueprint. Now we will encapsulate our notes with comments to give other developers know what is our goal with each step. Comment is the helper text to help other developers as well as you at what is your aim by creating this particular piece of notes, which also keeps your blueprints more goal-oriented as you are describing each step in the comments. Let's now go into the Unreal Engine and see how you can add comments to your blueprints. In your event graph or blueprints, you can easily set comments by selecting all of your nodes and pressing the C button on your keyboard. While writing your comments, you should also have a standard. If you start with a verb, then in your all comments, you should start with a verb. For this particular example, we can write setting ammo count. After setting this comment, we can change its comment color in the details panel by clicking the comment color button, or we can change the font size with slider or typing manually. We can also choose the show bubble when zoomed option. If we choose this option, when we scroll our mouse wheel down, the comment will still be visible. And if your blueprint is really big, then you should easily navigate with these bubbles. You can also color bubble or change the move mode of comments. Like if you change this from group movement to comment, when you change the position of your comments, the nodes will still. But if you select group movement, then your nodes will follow your comments. We learned that we can encapsulate our blueprints with comments to improve its readability. However, there are times that your blueprints is just too long and hard to follow, and includes steps that each can be grouped individually. To divide your blueprints into groups, we have an option called collapsing nodes. Collapsing node takes selected nodes and collapse them into a single node inside event graph. This way, they are more organized and easy to follow for other developers. For this particular example, we have two different executions. One sets the health to 100 and the second one sets armor to 50. Both executions serves the same goal, which is setting the player attributes. So that we can select all of these nodes, right click, then we can select collapse node under the organization tab. Our selected nodes collapse into a single graph. Then we can name them as setting initial attributes. By clicking this collapse graph, we can look into the details and the application of our exemplary variables so that we can encapsulate our algorithm and divide them into smaller parts. In the previous part, we learned that we can collapse group of nodes that have single purpose to improve our overall logic's readability. Now we will see different type of collapsing, which is collapsing to a function. Collapsing to function does similar thing, except it has some pros and cons comparing to collapsing nodes. Collapsing to function creates a function that is similar to creating a one manually. Therefore, similar to casual functions, you can't use overtime events such as delay and timeline inside a function. However, you can use this function inside your blueprint to omit repeated code blocks. Let's now go into the Unreal Engine and see how it's done. Such as collapsing nodes, you can select all the execution nodes and right-click to them. Under the Organization tab, you will find Collapse to Function option. By clicking on it, it will create a new function for you. You can rename it such as set default attributes. Then you can use this function inside your blueprint. In the last chapter, we have seen the collapsing option for nodes having same specific goal, but sometimes collapsing nodes doesn't have enough impact on improving readability. Now we will learn two blueprint nodes that help you improve the readability of your blueprints. One of them is sequence node. Sequence node, as the name suggests, lets you plan your algorithm in a sequence, one step at a time. This way, you can divide your algorithm into smaller parts to help you stay organized in your blueprints. Let's now go into the Unreal Engine and see how sequence node is used. In this particular example, in event begin play, first we set default attributes, then we set is weapon equipped boolean, then we will set the ammo count to 0. As this graph gets more complicated, it will be harder to read it line by line. It will be harder to read it in order. So that we have a sequence node. You can drag from the execution pin and search for sequence so that we have a sequence node. In sequence node, we will execute our algorithm line by line. The first thing that will be executed is then 0, which will be set default attributes. After setting default attributes, I can easily set weapon-related variables. I can add more pins by clicking the plus button, and I can even set individual comments. By doing so, our algorithm is divided and easier to maintain. In the previous part, we learned that we can increase our algorithm's overall readability by using sequence nodes, since it allows us to put our blueprints into order. Now we will continue with our second blueprint node, which is flip-flop node. At the first sight, these nodes seems to do nothing with the readability of our algorithms. But since its simple flip logic helps us to avoid unnecessary Boolean usage. Flip-flop node starts with the execution of A, and when we enter this node again, it continues with the execution of B. As the name suggests, whenever you enter these nodes, it flips. So you don't need to switch extra Boolean from false to true and check its value. Let's now go into the Unreal Engine and see how it's used. In this example, when E key is pressed on the keyboard, it first checks if is weapon is true or false. If it is true, then it sets its value to false. If false, it sets its value to true. But there's unnecessary usage of is weapon equipped blueprint here. Instead of using this boolean excessively, we can use a flip-flop node. As the name suggests, when E key is pressed, which means when it first enters this flip-flop, it sets its value to false. And when it enters it again, we can set is weapon equipped to true. Therefore, we don't have to check if is weapon equipped is true or false. Whenever we press the E button on the keyboard, it flips, which means switches its value automatically. In the previous chapter, we learned two new nodes. Sequence helps us organize our blueprints in order, and flip-flop node helps us omit unnecessary Boolean usage. While these two nodes are helpful to organize our blueprints, untidy blueprints are still troublesome to understand. Aligning nodes is the undervalued technique that is highly beneficial to follow our nodes. We have to follow three simple rules while aligning our blueprints. First rule is that, if possible, all wires should be straight. Therefore, you can follow the order of execution easily. The second rule is connected to the first one. If it is not possible to make every connection straight, then you should make the execution wire straight so that you can easily follow the main execution line of your algorithm. The third and final rule is that use reroute nodes wherever possible. The third and final rule is use the reroute nodes wherever necessary. Rerouting spaghetti nodes can be a huge lifesaver dealing with the complex algorithms. Let's now go into the Unreal Engine and see how these rules can be applied to our project. In this particular exemplary function, we have two inputs, in health and in armor. Then we set health variable and armor variable. But as you can see, if we try to make these execution pins straight, then we will have difficult time to read the float wire coming from armor, coming from in armor to set armor's variable. We have different options here. For example, we can double click the float wire here, then we can drag and drop this pin so that everything will be aligned in order. The other option is we can right click inside a function and search for input variables. For example, in armor, get in armor. This is local variable, which means it is only defined inside this function. Then we can use this in armor variable to feed directly set armor, and we can select this reroute pin and delete it. Therefore, our blueprints will be easier to understand and read. Thank you for watching and wish you more organized and cleaner blueprints.